All right, so let's begin. I have started the streaming and I have pasted the link for this session in the chat as well as in the calendar also. You can come back and watch this later. Okay, so before we begin, I have a couple of updates with respect to Math 1. So, most of you would have already seen the calendar. So, we have scheduled 2 revision sessions, right? So, one is tomorrow from 4 to 6 p.m. You can join using the same link. It's also available in the calendar. We will be revising week 1 and 2 tomorrow. Okay. And on Friday morning, 10 to 12 is the second revision session where we revise week 3 and 4. And parallelly, we'll also do mock, which has been released already on the portal. Please open your portal and try to attempt the mock. So, mocks helps you to boost your scores for qualifier or quiz. Okay. So, these are the two things. Try to attend the revision sessions and try to attempt mock. Okay, so these are a couple of things I would like to inform you guys. And today we will do a very short session, maybe at max of 1 or 1 hour 15 minutes, where I would like to deal on the doubts that you have. So if you have seen the session name also, it's like doubt clearing session for week 2. So if you have any doubts related to week 4, if you have any doubts related to week 4, I will address it. Any theory related doubts or any doubts related to questions, assignment questions, we will discuss. Okay, so yeah, let's begin. That's the main agenda for today's session. Just to clear your doubts, and I wish you a happy and safe Diwali to all of you. And let's begin. Okay, so if you have any doubt, please raise your hand. I'll call out your name, then raise your query or doubt, and we will solve that. Okay. Yeah. Anyone? Okay, so is week 4 okay? Like easy concepts? Or is there any concept that is difficult to understand now? So these things, I think this is the very starting point of calculus, right? So limit, continuity, and limit of a function, continuity, and limits at infinite. So these are the three important concepts that you should definitely work on. Okay, till one of you starts your doubts, let me tell you a few things about week 4. Okay, or something like the skills that you have to develop with respect to week 4 concepts. Okay, so I'll name it as skills. Skills that need to be developed. Okay, so what you should learn is, first of all, you should be able to comment on existence of limit at a point. Okay, so you should be able to comment on the existence of the limit at a given particular point. So you will be given a function, right? So you will be given a function from R to R, either in mathematical expression or graphical way, right? So graphical way is much easier, but if it is given as f of x is equals to something, like let's say x square plus 5x plus 4 divided by x minus 2, something like this, right? So the domain is not R, it is R minus 2 will not be in the domain, right? So some function like this, and you should be able to comment on existence of the limit at a given point, at a particular point. Let's say point is x is equals to 3. So how do you comment on the existence, right? So what you should do is, the best way to do is compute left hand limit, compute right hand limit, right? So what is left hand limit? It is limit x going towards 3 from the left side. So we denote it as 3 minus f of x, right? So that is left hand limit. And you should also compute the right hand limit, which is x is approaching towards 3 because the point is 3, right? So we are interested at this point. So you should compute the right hand limit, which
Sir,
is,
excuse me.
yes,
Sir,
yes, yes, yes.
sir, I have a doubt. Sir, I have a doubt here. How can we take the point x is equal to 3 for determining left hand limit and right hand limit? Sir?
Sorry, can you repeat? I kind of
Uh,
lost.
how, how can we take x is equal to 3 as a point to determine left hand limit and the right hand limit?
So you are asking, is it about why only 3 or why not something else? Or
Yeah.
so it's just like at any point, I just took randomly point 3, that's it. Point as 3.
So at
So
random,
yeah, yeah. So it's like given any point. So this is given.
x is equal to a
A is
at a,
3 here.
a 3.
So
Any point we can take.
any point, for
But
example, I
except
took x
except
is
two,
equals to 3.
sir,
Huh,
except two.
at x is equals to 2 is not in the domain,
Then,
but you can still find left hand limit and right hand limit, right? I will compute and show you how to
sir.
compute that. Okay.
Mm.
So at the point x is equals to 3, it's very easy. But at point x is equals to 2, we'll see how to solve that. Okay.
Okay, sir.
Uh, but in general, if you want to comment on existence of the limit, like whether the limit exists at this particular point or not, you should compute this left hand limit and right hand limit. And then how do I decide whether the limit exists or not? So limit exists at x is equals to 3 if this left hand limit and the right hand limit, or, or right hand limit is equals to the left hand limit. If this happens, then the limit exists. The other case is limit does not exist. DNEs does not exist at x is equals to 3 if the same thing limit, the right hand limit is not equals to the left hand. Okay. So firstly, you have to compute the left hand limit and right hand limit. How do you compute the left hand limit and right hand limit? So for left hand limit, we have to compute the function value where the function is approaching when the x is approaching towards 3 from the left side. So we have to compute this. And we know f of x is x square plus 5x plus 4 divided by x minus 2. right? So first and for what you can do is you try to substitute 3 in the given function. If things are okay, going well, then you can substitute it. If things are turning out to be 0 by 0 or something like it is going to plus infinite or minus infinite, you should be little careful. So this is basically at x is equals to 3, this particular function that I have taken is very smooth. So left hand limit, you can directly substitute or it approaches to the function value itself. So 3 square plus 5 times 3 plus 4 divided by 3 minus 2. And you'll see that 9 plus 15 plus 4 divided by 1. So this will simply be 28, which will be the right hand limit also. So even if you compute the right hand limit, this is what you'll get. But you will get the right hand limit. This will be equals to the right hand limit. And what does this imply? This implies that limit exists at x is equals to 3. Now what if the point is, now the second case is the point that we are interested is x is equals to 2. Okay, so x is equals to 2 where f of x is this one. X
Sir,
square plus 5x. Yes.
sir, excuse me.
Yes.
Sir, just we have found out the limit at x is equal to 3, sir.
Yeah.
Left hand limit. Left
Hmm.
hand limit by using, in place of x, we are using 3.
Yes.
Uh, how can we find out the right hand limit, sir?
Right hand limit also the same, right? So even from the right hand side also, you see that
By using
there
the
is
same
no,
number 3,
yeah. So there is no difficulty while x approaches to 3, right? So you can directly substitute it, right?
so we can use 3 for both the right hand and left hand limits also.
Yes, because when you substitute 3 in the function, it is not creating any difficulty, right? So it is not giving you some absurd values like 0 by 0 or something. So you can substitute it.
Ah,
Okay. Whereas when x is
okay,
equals
sir.
to
Okay.
2, you will see the difference. Okay. So when x is equals
For
to
right hand,
2, yeah.
for right hand limit, we are taking the values from right towards 3,
Yes.
But how
Yes.
can
But
we say 3?
ultimately it approaches to 3, right? So it is like
3.
3 point. So what is the function? How is the function behaving at x is equals to 3 point, some 100 zeros and then 1? And how is the function behaving when x is 2 point, some 100 nines? Right? So that is the left hand limit and the right hand limit. At x is equals to 3, what happens is 2 point some 100 nines will give you almost the same value as 3 point some 99 zeros and 1. You understood? Because at x is
Yes, sir.
equals
Yes,
to
sir.
3, it is very smooth. Now, after seeing at x is equals to 2, you will get much more clarity. Okay. So at x is equals to 2, when x approaches to 2 from the left hand side, what will happen to this function? Right. So limit x tends to 2 minus x square plus 5x plus 4 divided by x minus 2. Right now, I cannot directly substitute 2. Why? Because if I substitute 2, the denominator turns out to be 0. But the numerator is still an real value. So some real value divided by 0 gives me infinity. Right? So it's like not a real value. So therefore, you cannot directly substitute. Instead, what you can do is you try to, so x approaching to 2 minus means x is something like 1.9999999. Okay. So x is approaching to 2 from the left hand side. So it is coming close to 2 from the left hand side. And the closest value you can think of is 1.999999999, right? So when I substitute this value, what will happen to this function? So the numerator is still a real number, but the denominator, you can see 1.99999 minus 2. So it's like this x is smaller compared to 2. So it will give us some negative value, which is very, very, very minute, right? Something like minus 0.0000000, some many zeros, 1. And the numerator is this 1.9999 whole square plus 5 times 1.999 plus 4, which is still a real number. And even the denominator is very, very low. If the denominator is very, very, very less, the whole value becomes infinite, like almost the large number, right? So when denominator is lesser, the ultimate value turns out to be very, very big. And there is some minus here. So very big number towards the negative side. So this will go to minus infinite. Go towards minus infinite. Is this okay? Is this understandable? So I'm not using any math here. Okay. So all I was using was general sense, right? So what will happen to the function when the domain value comes towards 2 from the left side? So if it is approaching from the left side, the denominator turns out to be a small negative value. So when the denominator is very small negative value, when it goes to the numerator, it will go to the numerator, right, with a huge value that will get multiplied to the numerator, and ultimately it goes towards minus infinite. Whereas if you see the limit of this function, the right hand limit at point 2, where the x values are slightly greater than 2 and start approaching towards 2, right? So what will happen to this? X tends to 2 plus x square plus 5x plus 4 divided by x minus 2. So when it is coming from the right hand side, x values you can think of like 2.00000 someone, right? So many zeros. So you can, it can be 1,000 zeros or 10,000 zeros, or you can put as many zeros as you can, and then 1. That is still greater than 2, right? So if I substitute that in this function, again the denominator turns out to be a very small value, but this time it will be positive, right? So 2.0000001 minus 2 will give me 0. Many zeros and 1. And the numerator is again the same, 2.01 whole square plus 5 times 2.0001 plus 4. Still a real number, but the denominator becomes very, 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 very small, very close to 0. That means the whole expression goes towards infinity, and there is no negative sign also this time. So that means this goes towards plus infinite, right? So the left hand limit is definitely not equals to the right hand limit. Therefore, the limit at this particular point does not exist. Okay. So that's the first skill that you should develop, where you should be able to tell at what points limit exists for a particular function, at what points limit does not exist. Okay, so that's one point. And the other skill that you have to develop is about not only commenting, you should also able to compute them. Right. So compute limit of a function at some point x is equals to a. Again, for example, if I take f of x is given to be something like this. So x square plus 2 when x less than or equals to 1, and let's take x power half plus 3x minus 1 when x greater than 1. Okay, so and we were asked to compute find the limit of a function of the of f of x at x is equals to 1. Okay, so how do I compute? Again, the same thing. I have to compute the left hand limit, I have to compute the right hand limit and check whether they are equal or not. If they are equal, then that becomes the limit of the function at x is equals to a. Right, so the left hand limit at x is equals to 1 is this expression, and this is limit x tends to 1 minus. So when x is approaching 1 from the left hand side, how is the function behaving? Anybody? So which function should I choose? X is coming towards 1 from the left side. Come on, you should tell this.
Sorry, x square plus 2.
Correct. So f of x behaves like this. Now when I substitute this 1, it gives me a nice result, right? So there is no difficulty. Therefore, I can substitute 1. If I substitute 1, I'll get 1 square plus 2, which is 3. On the other side, I have to compute the right hand limit when x is approaching towards 1 from the right side. So that means x values are greater than 1. If that is the case, then my function behaves like x power 1 by 2 plus 3x minus 1. So here also I can substitute 1 with no difficulty. So 1 power half plus 3 minus 1, which gives me 3. So we can clearly see that the left hand limit and the right hand limit both are equal. Since they both are equal, 1 minus f of x is equals to limit x tends to 1 plus f of x. This is equals to the limit of a function at x is equals to 1. So that's it. So computing left hand limit and right hand limit are essential for anything. So even for continuity also, this is the starting point. So you should compute left hand limit, right hand limit, then see whether the limit exists or not. If exists, what is the value? So the value is basically the left hand limit or the right hand limit. That will be the limit. If they are not equal, then limit does not exist. Okay, so these two things you should really develop, and then comes commenting and computing on continuity, right? So you should be able to comment on continuity of a function at a point x is equals to a. Okay, so there is a slight difference. You can call it as extension to limit, right? So for continuity, there is an slight extension or condition, extra condition that needs to be satisfied for continuity. So for limit, all we want is whether this left hand limit is equals to the right hand limit or not. So this is, so the question mark denotes that whether this is equal to or not. So this is the condition for limit existence. For continuity, an extra condition is whether this, if at all these two are equal, whether these two are equal to f of a or not. So this checking is for continuity. Okay, so it's like one more added condition to the limit existence. All right, so again, for continuity, you have to start from the limits itself. You have to check left hand limit and right hand, you have to compute left hand limit, right hand limit, and check whether these two are equal or not. If they are not equal, there is no point of checking for continuity. You can stop right there. So if limit does not exist, it will not be continuous also. Whereas if limit exists, again you have to check whether the limit, the left hand limit and the right hand limit that you have computed, are they equal to the function value or not. If they are equal, then it is continuous. If they are not equal, then it is not continuous. All right, so the limit value should be equals to the function value. And let's take an example. And these skills you should develop definitely. At least for quiz 1, there will be some questions related to this. Okay, so let's say you have a function like this, ax square plus 5 when x is less than 2, and some p when x is equals to 2, and let's say x or half. Let's take x cube minus 3 when x greater than 2. Okay, so I'm taking it in general. So let's say this is the function and we are interested at x is equals to 2. At x is equals to 2, we wanted to see for what values of a, or if a is confusing, let's take some q. Okay, so p and q are some real numbers. So we'll see whether this function is continuous or limit exists at this point x is equals to 2. If at all at x is equals to 2 it has a limit, then what is the values of q? If at all it is continuous at x is equals to 2, what are the values of p? So we'll see them also. Okay, so at x is equals to 2, if I compute the left hand limit, right? So x is approaching towards 2 from the left side. So that means x values are lesser than 2. So when x is lesser than 2, my function will be q times x square plus 5. So it's just a quadratic function. So there is no difficulty to substitute 2. So q times 2 square plus 5, which is 4q plus 5. Okay, and the right hand limit is when x greater than 2, When x greater than 2, it is x cube minus 3. And again, I can substitute 2. This will give me 2 cube, which is 8. 8 minus 3, 5. Okay, so the left hand limit is 4q plus 5. Okay, so let's do this. Let's change the value slightly because q is coming out to be x cube minus 2. Okay, so I just change it for better answer. So let's say 6. Okay, so left hand limit is 4q plus 5. Right hand limit is 6. So if the limit has to exist, then these two must be equal. Right? So if these two, if I equate these two, I'll get 4q plus 5 is equals to 6. This implies q is equals to 1 by 4 or 0.25. So that means, what can I say? Limit exists at x is equals to 2 only if q is equals to 1 by 4. Right? And the other statement is limit does not exist at x is equals to 2 for q not equals to 1 by 4. So for any value of q other than 1 by 4, the left hand limit will not be equals to the right hand limit. Therefore, limit does not exist. Once limit does not exist, it will not be continuous also. Okay, so any q that is not 1 by 4, this function is not continuous at x is equals to 2 and not does not have any limit at x is equals to 2. Okay, so only at q is equals to 1 by 4, the function has limit. Okay, so now for continuity, first of all, limit should exist. Therefore, we have to take q is equals to 1 by 4 and proceed. So take q is equals to 1 by 4 and proceed. Okay, so if I take q is equals to 1 by 4, then the left hand limit and the right hand limit will be equal and both of them will be, so these two will be, if I just substitute, both of them will be 6. 4 times 1 by 4, you can see here. 4 times 1 by 4 is 1. 1 plus 5 is 6. So this will also be 6. This will also be 6. Okay, so this is the left hand limit and the right hand limit. Now the function value f of 2. Right, so this is the function value. So at x is equals to 2, function is just p. Right, so f of 2 is p. Now again, we have f of left hand limit and right hand limit to be equals to 6 and the function value as p. I can comment on continuity here based on the p values. So if p is equals to 6, which is like the function value is equals to the left hand limit and the right hand limit, then the function is continuous at x is equals to 2. Right? Else not continuous. Okay. So you should be able to solve problems of this type also. This skill also very, very important. So there will be a function given to us with some continuity conditions or limit conditions. You should be able to compute the missing values. Okay, so this is also a skill that you should must and should develop. So it's like I will mark it in the red. So you should be able to compute the missing values in the function based on the limit and continuity conditions. Okay, so there are many problems in the portal also. Try to solve it. I think even in the mock also you'll see one such problem. Okay, so this is also a really important skill that you should must and should develop. And the final one is important for understanding these concepts better. So you should be able to roughly plot any given function on xy plane. Okay, you should be able to roughly plot, and you can practice it or verify it using Desmos tool. Okay, so this is also important. And yeah, so these are the key skills that you should really develop with respect to week 4. Okay, so practice a lot of
So,
problems related to
sir,
this.
the
Yes.
third skill, the compute the missing values in the function based on the limited
Mhm.
continuity condition. That is what
Mm-mm.
we have seen in the previous
Yes,
one.
yes, yes. This one is
Okay, sir.
same thing.
Okay. Ah, okay, sir.
Okay, yeah.
Ah,
And all right, so these things are really important. I just wanted to mention it here and practice more problems. We will be revising all these things again on Friday. So as I said, tomorrow we have revision session week 1 and 2 from 4 p.m. to 6 p.m. And the second revision session is on Friday morning 10 to 12 p.m. Okay. So yes. So
sir, I
anything
have a doubt.
else? Yes, please.
So actually, really, I thank you, sir. This is what I intend to ask you, sir. The
Yes.
skills.
Hmm.
I really thank you very much, sir. Sir, while calculating limit,
Hmm.
when we will apply L'Hospital's rule or binomial
Okay.
approximation?
So binomial approximations, you don't need to worry. Right now, we are not going to deal with those concepts. So, and even the L'Hopital also, we will be discussing them in the coming weeks. So derivatives are required for using L'Hopital, right? And I saw most of you guys use L'Hopital for sequences, which is not true, which is a blunder in math. Okay, so sequences are discrete, right? So I think I haven't taken session in week 3, but you should be able to understand the difference between limit n tends to infinite an and limit x tends to a f of x. There is a huge difference between these two limits. Okay, so this is limit of a sequence an, where nth term is an, and then you try to compute where that particular sequence approaches to, right? So is it converging or diverging, or so this is limit of a sequence, and this n is basically a natural number, right? So n takes values 1, 2, 3, 4, and so on. Even if you have plotted this with respect to n, ans with respect to ans with respect to n, you would have seen graphs like this, right? So you would have seen plots like this. right? So this is not a function, first of all. Sorry, this is a function, but this is not continuous function. So if you plot also these dots you see, right, red dots, these are the function values, and it is like discrete, like it is placed in the on the xy plane at different places, right? So this function is not continuous at any point. If you think of this as a function, this function is not continuous at any point. Therefore, you cannot apply any differentiation related rules on these limits. If I have to be more specific, you cannot perform any L'Hopital rule or any other rule which uses differentiation with respect to sequences. Okay. Whereas coming to the functions, some functions are continuous, and among them some functions are differentiable also. Functions which are differentiable, okay, then, and if you consider a rational function, only then L'Hopital rule may apply. Okay, and we will discuss this L'Hopital rule in the next week, very next to next week, which is week 6. Okay, where once you understood this derivatives of a function and how to take the derivatives and differentiability, then comes applications of this derivatives. In that applications, we will see one application is using L'Hopital rule. We can compute limits for some indeterminate forms, which are 0 by 0 or infinity by infinity. Okay, so in qualifier contents, like at least week 1 to 4, there will not be any question related to L'Hopital rule. Okay, so, and don't blindly use L'Hopital on sequences. That's the only thing I wanted to say here. Okay, after this qualifier exam during week 6, we will in detail discuss where to use L'Hopital and where not to use L'Hopital. So, right, so we'll discuss that in week 6. And take this, limit of a sequence is different from limit of a function. Okay, and we'll see all these things in week 3 and 4 revision sessions. So we'll combinedly look it into the important concepts and how to solve any given problem. Okay, so we'll lie in within the quiz 1 syllabus. Okay, I hope that is all right.
Sir, one quick question.
Yes,
In the graded assignments for week 4, there is a limit question. The variable for the function is x, but I don't know if it is a typo or not. But the limit which we have been asked to calculate it, there the variable which is tending to infinity is given as n.
You should take it as x
Only.
only.
Right?
Yeah.
Okay.
So there is no n at anywhere, right? So it is x only.
Right.
Yeah.
Okay.
So in week 4, there will not be n in most of the places. It will be only x.
Yes.
Okay. Yeah. Yes. Any other doubts from anyone, or else we can close this and meet tomorrow evening 4 p.m. Okay. So the coming week. Yes.
While computing limit of sequence, n tends to infinity is limited. While computing the limit of function, x tends to a. What about x tends to 0?
That is a can take any value. Like a is
Any
like
value.
anything. So whatever they ask, if they ask to compute limit at 0.0, a becomes 0. If the limit at 0.3 or 0.5 or somewhere, it will become that value. And these limits are also different. These are called asymptotes. Extends to infinite
But as
f of
far
x. Sorry?
but as far as sequence is concerned, definitely n tends to infinity only.
N should tend to infinity only. That is the limit of a sequence mean.
Limit. Okay.
Right? So what will happen to the sequence terms at the last? At the last. Right? So
Yes,
last is
yes.
something like n is going to very near to infinity. That is the limit of the sequence.
Hmm.
Okay?
Yes, sir. Yes, sir.
Yeah. So don't get confused with limit of a sequence with limit of a function.
Yeah.
Okay. Anything from anyone then? Okay. So as I said, today is still Diwali going on. So we'll have a simple lighter session. Tomorrow we will revise week 1 and 2. Please come with a book and a pen along while you join the session. Okay. So we'll solve problems as well as revise the concepts. And these are the last 2 sessions that are left for quiz 1 or the qualifier. Okay. So let's
Yes,
give
sir.
our 100%, if possible, more than 100%, and try to get good marks. Okay.
Thank you, sir. Thank you, sir.
All right, guys. Then let's meet tomorrow evening 4 p.m. So it's not 8 to 10, it's 4 p.m.
Thank you, sir.
Okay.
Thank you, sir.
Thanks a lot. Have a great day.
Thank you, sir.